computer audio. We are recording now, and although it said Brian Stevens 2 seconds earlier, now we are recording, and we got the actual Brian Stevens in here. So hey, take a seat, relax, find a decent spot. There's a chair right there if you like. And we do have a chair right there, so definitely if you have any chair near you available, make sure to give it to somebody. And we've got 2 chairs there if people want. They're just kind of facing each other. And if someone needs them who comes in, we can use them. This is where I can mute all participants. There we go. Everybody is muted. We are good to go. We're on time. So here's what we're doing. I think I can add in the points. You'll notice we're doing a Jeopardy game today. The biggest thing here is not who wins or loses, but if you pass tomorrow's test and make an A on it, right? So be taking notes. Have your notebook out. We're not going to be too concerned with winning or losing. Our main goal is to win. Is not to win. Our main goal is to do well on the test. So I am now screen sharing. Let's hop over here. Let's pin some videos on here, and let's go ahead and see what's going on. So remember, onliners, I need you guys to be quick in the chat. Also, be taking the notes. You'll hear some very important interpretations today. You should know by now your interpretations for things like what? What are 3 things we should know how to interpret in regression right away? And you can start typing them in the chat and try writing them down. Oh, yes. Did everyone hear that? Here are things you should know how to interpret right away. The 3 things are, slope is one of them. And slope would be for each oh my gosh, you guys are beating me out. Increase or decrease by B1 on average. Does that make sense? And let's highlight some stuff here. For each 1 unit change in X, we're not going to say that. We're going to put it in context. And for Y, we're going to put that in context. Increase or decrease, we won't say both of those. We'll look to see if the line goes up or the line goes down, and then we'll also put this in here. I tell you what, maybe we'll start with an example. Regression is one of the latest chapters. Maybe before Jeopardy, we'll do a little interpretation test right here to see if you guys got it down. And let's write out a very simple equation right here where we want to predict how many, I'm so hungry, guys, burgers equals, and let's go here, 0.5 plus 2 times fries. This might not make any sense. Let's talk about this equation and what it means right here. Let's make it test relevant. Here's your test grade. And let's change this here to 60. And let's go here to hours studied. Okay, now it is test relevant. We have an example now, and we also have some interpretation. So let's try, and let's see online, try to do it. So be typing it in the chat. So let's try to interpret the slope in context of this problem. So who wants to raise their hand online or in class? Go ahead and give it a shot.
For each hour studied, we expect the test rate or by 2.
By 2, yes. And then here's the biggest thing. Great job there, and I'll repeat the answer so online can hear it. For each additional hour someone studies, we expect their test grade to increase by 2 points. And there are teachers who are very big sticklers on this. I don't care, but if you're in here from another class, maybe we should. Some people really love this on average saying at the end. So some people are very big on having on average. I mean, sure, why not? So if you've heard people say the on average part, it never hurts to add that on. My graders will not be taking off for on average. I can't promise all graders won't. I don't think it's that big of a deal. But for each additional hour someone studies, we expect their test grade to increase by 2 points on average. So we're doing like the super saying right here. It's like the best one we can possibly do. So let's do the intercept. Who wants to give me online or in class the blanket kind of standard interpretation for intercept? Yes. So when x is equal to 0, we expect y to equal b0. Now remember, we're going to put these in right here, and we're only going to change these parts of our saying. Now, of course, you can say it many other ways, but it doesn't hurt to have a standardized form in saying it because it'll help to make sure you don't make mistakes. The biggest thing you should know is that this regression equation we are seeing here visually, when you look at this right here, this is actually, let's go to insert equation. This equation you are looking at, if I find the insert button, The equation is, we've got really fancy symbols in here. There is the hat. It is actually y hat equals, ooh, that's not right. We'll go back in time. There we go. Y hat equals, and then we need to do a little b naught plus, and then we need another one, b1x. So the equation you see below, I want you to look at the format here if you're wondering how we know which thing is which thing. Right here is B0. Does everyone see where that lines up with the equation I've just written in? So, and I like they're doing it online too. Nice job, Courtney. 50 points, 50 points over here. We toss that extra credit around today a bit. So with this in mind, you can see that what I've highlighted is B0. Y hat stands for predicted value of Y, as in someone's predicted test grade. Now you can say test grade, but we know it's a prediction. We're not saying, you will make this. Like if you study 20 hours for the test, this says you'll make what on the test? If you study 20 hours, it says you will make 100. And does everyone understand how we could use this equation to get a predicted value? So we can use this equation to make predictions. That's how this would work right here. And then nice job online too, Sydney and Caroline. And then B1 right here is the value of the what? The slope. And you notice right here we have x, which is the name of the x variable. So you kind of see the difference between the regression equation, which I'll put in red right here, and then we'll put in blue the one in context of the problem. So you should be able to kind of understand what the general form looks like, and also the one in context. So this is the y hat, this is the B0, which is the intercept, and then this is B1, which is 2, and x is our studied. Now, how would we, in context, go ahead and raise your hand, how would we interpret the intercept in context of the problem? And I'll do a follow-up question. Who wants to raise their hand and give it a shot, and be writing these down, because you could be writing them on the test. Go ahead, give it a shot.
Is it when hours studied we expect the test grade to be 60?
Perfect. And did you hear the context right there? When hours studied, well, that means when someone has studied 0 hours for the test, we expect their test grade to be 60. So when x is equal to 0, and just think about it mathematically. If x is equal to 0, well, then what would this be right here? Can you solve this equation? You would just, this would equal 0, right? So wouldn't test grade be 60 when x is equal to 0? So you can kind of do the math right there and just plug in the value and see when x is equal to 0, we expect y to equal 60, which is test grade. And if you're trying to remember if B0 or B1 is the intercept, B0 because when x is equal to 0, B1 because for each 1 unit change. Little trick right there that we keep in our head. So it can be for each 1 unit change, or for each, I guess for each 1 unit change. For each, let me make sure it's in here, 1 unit change. There we go. For each 1 unit change, kind of rise over run, right? That is the slope, and that's why it's B1. So great job online, all those answers too. We have one last thing to interpret. It'd be nice if this was this. We're going to give an R squared. R squared is the percent of variation explained. And how do we find R squared from R? Correct. R squared is R squared. But if you have R squared to get correlation, you would square root. But we have to watch out, because if the line goes down, then correlation would be what? Negative. That's a big trick right there. So once you square root something, you have to look to see if it's positive or negative based on the line. So let's zoom out just a little bit here and look at our final interpretation, where we're going to look at R squared. So R squared is going to be the following. It's going to be blank percent of the variation in what? Y is, and I really like to make that X very clear, because X explains Y. So blank percent of the variation in Y is explained by the variation in X. Nice job online. We're doing like a mega review right now. We'll do some Jeopardy, and then we'll do some cleanup at the end to see if we missed anything. But let's see right here. Can you interpret this R squared in context of the problem? This is kind of a quick review of regression. Does everyone hear that? 80%, which is R squared, you turn it into a percentage. 80%, nice job, Yeon. 80% of the variation in test grade is explained by the variation in hours studied. all we're doing is we're just taking where test grade is at, and we're just dropping that down into the Y part. We just drop that in right here. We take hours studied, and we drop this in right here, and we take that 80% of the R squared, and we drop it in right here because we turn it into a percentage. But this is the key to understanding and doing it in a way that you won't make mistakes, is you just drop it into the interpretation. So with the notation right here, we can see 80% of the variation in test grade is explained by the variation in hours studied. So a little bit here, remember this is recorded, so you will be able to go back and kind of see these things and make sure you have them written down correctly. So can you give us an example of a way a regression will show up on the test? Yeah, why not? You guys like doing regression problems? Like right now? Maybe?
Are you always going to get the R squared?
Yep, we could ask you to calculate it from correlation. That is possible. We won't make you calculate it from hand, like by the start of it. But how could we ask you to find correlation from R squared from correlation? Square it. Does that make sense to everybody? So what I'm going to do is I'm going to go over to the project. Project 1 data is still available. And what we're going to do is we're going to do a regression right here and do our own interpretation. So let's look at some jump output here and be able to interpret the jump output and see if we can do regression. So we're going to go to Analyze, Fit Y by X. If you're still doing the regression homework, this is how to do your regression homework using jump right here. So let's go to Analyze, Fit Y by X. Let's see if somebody's, let's do something very obvious. Let's do if their weekly text can be explained by their weekend text. Oh, let's do this. Let's see if how much someone texts in a week explains how much they text in a weekend. Does that make sense? And let me increase font size here, make it nice and big for you guys. So weekly text is explaining how much you text in the weekend. And they're kind of aggregates of each other, so it's logical to think how much you text during the week explains to some degree how much you text on the weekend. And let's see if I was right. And do you see a kind of positive, ooh, I see a big thing with this QQ straight enough, no outliers. Can I get, you guys gotta wake me up. What are the 3 conditions for regression? What? What was that? What are the? I'll throw you 500 points. I'll let. Who was that?
I said it too.
You was louder. I respect that. You got. When I used to do this with the whole section, I used to see if anyone could be louder than me, and I would hurt my voice yelling so loud. I respect that. QQ straight up, no outliers. Mark, you're the first person yelled online. Are you, Mark? You get the 500 online, first person to yell it. Throw out some mega points today. QQ straight up, no outliers. But we commonly get the question, what does that mean? What the heck is QQ straight enough, no outliers? What's going on? Why is Brian class yelling this? Someone raise their hand and explain to us. Go ahead. What is QQ? Oh, let's pause on this one. You are correct. Thank you very much. 100 points to you, sir. So QQ means 2 quantitative variables. Better representative, especially if you're not in our section, by quantitative variables. I abbreviate it QQ because 2 quantitative variables. How on the test would you tell them on the test that this is 2 quantitative variables? What would you say? Go ahead, sir. Well, yes, weekly texts and weekend texts are both quantitative variables. That's all it's saying. Then the second condition, who's got that one? Mary, answer any questions, 50 points to you today. Who's got the second one straight enough? Go ahead. And yes, but if the test question said, is straight enough applied here? Is this straight enough? It's not?
You could draw like a linear line.
A line represents the relationship. And we did this one at random because the issue with this one is what? No outliers, right? And you want to say something passes conditions. Here's the hardest thing about saying no outliers. You might want to say no outliers, yes, or no outliers, no. I think it's easier to say we pass the no outliers condition, right? We either pass or fail the no outliers condition. So how would we pass the no outliers condition? If there are no outliers. Are there outliers? There is an outlier. Now, what I would do on the test is I would take and I would put a little circle around this or something, and I would maybe explain to them on the test that there is someone who has 100 weekly texts and 1,000 weekend texts. They just go crazy on the weekend. I want to know about this person, though, that during the week they don't text at all. Or no, during the week they text and they just put their phone up on the weekend. Weird, right? So we see a bunch of interesting stuff right here. We do have a little bit of plot thickening, chapter 8, not on this test. But with this right here, we do have an outlier issue, and I would circle it. And then would we pass or fail the no outlier condition? We would fail. And I would say there is an outlier, and so we fail the condition. The outlier, and I would circle it, and I would say a person who has 100 weekly texts and about 1,000 weekend texts. That's very clear to the greater than. This person is an outlier. We fail the condition. QQ straight enough, no outliers. So let's go ahead and fit our line right here and try to do the math. I'm going to clean up the numbers a little bit for you right here. Let's clean them up. Let's remove this because that's just the name of the variable. That's removed. And let's remove this right here, the name of the variable. And let's delete the decimals down to 1. So this is a really kind of rounded version of the problem. But does everyone see we now have the equation? And let's see if it makes sense. Try to do this right now. Try it on your sheet of paper. Interpret in context for me, and I'll put this over to the side. Interpret in context the r squared. Interpret in context the r squared. Interpret in context the r squared. Here, I'll put it so everyone can see. And I think, oh, let's got r squared right there. So you should be able to see everything on the screen right now. Interpret in context the r squared of this problem. Let's go back in time to where this looked like this. So interpret in context the r squared. Try to do that right now. See if you can do the r squared and tell me, raise your hand and tell me if you want. R squared in context of the problem. Go ahead.
59% of the variation in weekend text, or the variation in
Perfect answer. 59% of the variation in weekend text is explained by the variation in weekly text. And don't worry, I would count that 100%. Sometimes we ask for 2 decimal places on the test. It'll say that very clearly at the start, round all to 2 decimals, but that's 100%. If my graders took off points and you talked to me, I'd be like, they know the concept. They got it. So you're great. How about let's do the intercept, and then let's ask a question we didn't ask a moment ago. Does the intercept make sense? And you might have a different answer on this. And nice job online. Who wants to do the intercept here to practice that? And we'll do some follow-up questions on this. Who wants to do the intercept here? Go ahead.
When weekly texts are 0, we expect weekend texts to
Which one's the intercept of these values? Bingo. When weekly text, when x is equal to 0, we expect weekend text to be equal to 10.7. And do you think this makes sense? Or did you have a follow-up question?
Yeah.
Go ahead. So that'd be correlation. We could find the correlation of this by square rooting. So it's actually pretty strong, surprisingly, although it looks more scattered. If we want to find the correlation, we could take r squared and square root it, and that's the correlation. It's actually moderately strong. Does everyone see how I square rooted r squared to get r? How do I know it's positive? Because what? Because there's a positive slope. Does that make sense? So we can instantaneously calculate r from r squared by square rooting it, but please check to see if the line goes up or down, or if the slope is negative or positive. So once you square root r squared, we can see the correlation, but we check to see if it's positive or negative. But this intercept, I would say, kind of makes sense. I know it's a decimal, but it's like, okay, people who don't text during the week don't really text during the weekend either, right? But on our previous example over here, did it make sense? And I kind of made it sound like it doesn't. Could you study 0 hours for the test? And then could you make a 60? That intercept is logical, but if I change this over here, watch for an illogical one, to something like height and weight, now interpret the intercept in context of this problem and see if it makes sense. When somebody's what? Weight is equal to, wait, what? Does that make logical sense? No, you can't say when someone's weight is equal to 0. I mean, you can say it, but it doesn't make sense. And even if they had a 0 weight or close to 0, would they be 60 inches tall? No. So does everyone understand what an illogical intercept is? An illogical intercept is when you look at the sentence you just said, and it either makes sense, logical, or does not make sense, illogical. It's logical to say, to reverse the problem, that if somebody studies 0 hours for the test, we'd expect them to make a 60. And we're not saying we know that is true, but it's like, okay, you could study 0 hours and you could make a 60, kind of makes sense, right? And then over here we said, okay, someone who doesn't text during the week, then they would text about 10.7 on the weekend. Even though that's a decimal, it's kind of like, okay, this is like on average, like if we were to average together the people who texted 0. So that would be pretty interesting. You might have to say if it's illogical or not. That is a possibility. So that is possible. That's what online's asking. Okay, so it still counts as straight. That is correct. The question online was, even though it's scattered here, does that still count as straight? Does the straight line go through the majority of the data here? Yes, that's what straight enough is, if a straight line's going through it. Now, there are relationships that are parabolic. Will that be straight enough? How about one that's exponential? No, a straight line does not well describe an exponential relationship. So all you're looking at with the straight enough is a straight line well describes the relationship between weekly text and weekend text. You kind of want to see that the line is between all the points, that the points don't kind of swerve around the line in any way. So that's what the straight enough condition is. Question? Yes, so you're asking about R squared and correlation, -1, 1, and 0. So the values, and we'll review this right here, the values of correlation, I always misspell it, it's 2 R's. I'll learn one of these days. Correlation is between -1 and 1, but when we square correlation, we get R squared. And R squared is between what and what? 0 and 1. And I want us just to think, if you square -1, you get what? You get +1. If you square 0, you get 0. If you square 1, you get 1. And R squared is percent of variation explained. What is the least amount of variation you could explain? It's like, what's the least percent of a pizza you could eat? 0, what's the most percent you could eat? All of it, 100%. So R squared ranges between 0 and 1 because it's the percent of variation you've explained. So it's related to correlation. And so think about this. If we have -1, that means we've explained all the correlation with a negative line, or we've explained all the variation, I should say. The correlation of -1 explains all the variation with a negative line. So every point would actually be on the line because it explains everything. So we need to say, yep, question there. So this has been pretty much a full review of, I'd say we reviewed at least 50% of regression like that. Should we just do the whole lectures like this from now on? We'll be done at 5:30, review over. Let's try some of these review questions here. If I really hate the review question, I set this up. Do we have the music? I hope we got the music. Enable content. Oh, it's good music. Do what? We're going to play some BS Jeopardy. This is so old. I haven't used, because I don't usually teach online or in class anymore. Don't worry. That's when season 3 of Vampire Diaries was on. This is so old now. Vampire Diaries got really bad. Does anyone agree with that? Like, no? You know I'm talking. Here's my, we're 200 points right there. You ever watch Vampire Diaries? Stefan, and you know what I'm talking about? Yes, exactly. Were you team Damon or Stefan? Yeah, good choice. All right. Back on topic. Let's do it. Damon, online says Damon. So let's get back on topic here and let's see where you guys want to go. Which questions do you have over what sections? And let's see which ones you guys have. Let's see if we can answer them. Pick the section and we'll talk about the topic. They all cover different topics. Which questions do you guys have? Statistical analysis for what? And then they got one online too. For how many points? 600. Divide these points by 10. I'll give that if you get it right. Quick draw question. Raise your hand to win. What is the median? So what is the median right here? Ooh, this is tricky. Do you know what the median is? Because I don't even know right now. All right, what is the median? It might be 150. How many? There's 9 values. So here's what we need to do with 9 values. So here's where we practice. You ready? If we have 9 values, what would we do to the median? How would we find the median? Take all the numbers. We do the little where you go like this, right? So we need to figure out what the values are. Where are the values? Stem and leaf. Up. So we need to know how to read a stem and leaf right now. Right? Online, you're Great job, all those points. So, so you got the 60 points right here, I believe. So if you notice, the stem and leaf says 11-0 is 110, right? So this goes to our question of bin widths here. What are the bin widths on this stem and leaf? This stem and leaf has a bin width of what? Question, go ahead, let me answer. 5. Because this is the lower 110s, this is the upper 110s. So if you take 110 to 120 and put it into 2 sections, how long would each section be? So you have like 110 or 110 to 114.9999999, 115 to 120. The distance there is how much? Does that make sense already? What are the bin widths of the histogram? How much? 10. Does everyone see what the bin widths are? Does everyone understand how to read the stem and leaf? Please raise your hand if you don't. We're covering as much as we can tonight. So here's how we read the stem and leaf. Each of these are the bins. So these are not real numbers. The reason it's blank right in here is that there's no observations. So I want to ask you what this 5 represents right here. But remember, it's an observation now. So that 5 represents someone's weight who was what? The weight of that individual with this 5 right here is how much? Does that make sense? This person, does it make sense? And then the lowest weight was how much on this? 110, does that make sense? So if you were to write down the numbers, try writing down these numbers now just to write down the people. The lowest person has a weight of how much? 110, the next has a weight of, then 145, because these are 2 people here, and then what? 148, and the 5th person has a weight of 150 with 9 numbers. The 5th number is the middle number. Does that make sense? And definitely write them down. That's a great way of doing it. Great job, everyone, right there. So it was a click and answer. Oh, wait. Oh, I got to go back to category selection. That's what I have to do. Okay, I think I saw online they wanted, I think, regression for 200. Let's see what the correlation. Oh, my gosh. Okay, we're doing correlation first. Oh, wow. Correlation ranges between what and what? Go ahead right here. You didn't, and I like that. If you really know what's going on, you'll get it online. They're getting it A, getting the answers, getting the points. Correlation ranges between -1 and 1. Could you draw for me right now online, or in class you'll see it. Try drawing it, a correlation that is -1. So the line would have to do what? Go down, and you'd have to put all the points directly on the line. What if we asked you to draw a correlation that was like 0.8? What do you know about a correlation that's 0.8? It's positive. Does that make sense, Ray? It's positive, pretty strong, but it's not, the tightness of it is the strength of it. If everything is perfectly on the line, the correlation is 1 or -1, depending if it goes down. And we won't do the flat line trick to you. Don't worry, that's a theoretical question. If we ever put that on a test, I'll be like, no, don't do that. So what is the correlation of a parabola? A parabola has a correlation of what? What is the correlation of a parabola? It's 0? Wait, so these points on a parabola have no relationship. There's not like an equation that describes a parabola? The linear relationship does not exist. A parabola like this does not have a linear relationship, so the correlation is 0 because correlation only measures what relationship? Linear. That's why we say QQ is straight enough, which is also a condition for correlation. A parabola is not straight enough to be well described by a straight line. So a parabola would have a correlation of 0, but it still has a relationship. It's just not described by a line. Does that make sense to everybody theoretically? Good job. Is it lightning outside, or is that just weird flashes of light? It's probably both. Lightnings are weird flashes of light. Ooh, I like this. What in the world are we going to have to do with this regression right here? Can everyone kind of see it? A lot of decimals, a lot of numbers. Interpret the y-intercept in context of the problem. Let's do an easier question to start. What is the y-intercept? What is the y-intercept? Go ahead. Do what?
The weak-long relationship.
Well, no, like what is the value of the y-intercept? Go here. What is the value of the y-intercept? Exactly. So does everyone see this is the value of the y-intercept, 92.47. Now I want to put a big hint out there with usually the test. The test does not usually ask, what is the value of the y-intercept? That's not usually the way we phrase it. If we say interpret the y-intercept in context of the problem, we're probably looking for a full sentence. So now let's try the harder question, and you can do 92.47 right here. So interpret, I love this graphic, I remember making it now. Interpret in context, and tell me about this individual, what you think about them. So actually, this is the weirdest thing, although it's very weak. Interpret in context of the problem, the y-intercept. Who wants to raise their hand and do it? Interpret in context, try writing it out in the chat, and try writing it down in class to practice. Go ahead. Mary, you get the 20 points right here. .47 weeks, exactly. I would just throw the decimals on there. And that's what I would say in person, 92-ish weeks. I agree, like I would throw that on there. So you're saying when somebody brushes their teeth 0 times a day, we expect their longest relationship to be 92.47 weeks. But look at the slope of the line. The slope is what? The slope is negative. Also, you see, we don't have any people who admit to brushing their teeth 0 times a day. So that's it. 5 times? Does anyone brush their teeth 5 times a day? I mean, I'll brush 3 times every once in a while. Like maybe, you know. Are
we talking like special days where like?
This is like their average. They're 5 times a day. They're got that every 3 hours. Brush your teeth.
You're not supposed to brush your teeth.
They're taking all that enamel off.
Yeah.
So great answers right here. I think the online's doing it too. And here's the biggest thing. Pretend this is the test. I know this sounds crazy, but as we're doing this right now, try to write down your answers. And as you hear people say answers, see how close you got. Because this is the way to practice right here, to like keep trying and getting it right. Yep, and it could be given in this format right here where the equation is. If you notice, this is your y hat, your predicted y value, which is why it's on the y-axis. This is your b0, which is the intercept. This is your b1, which is the value of the slope. And this is your x variable, which is the x variable. So great job. The winner is you. There's more with answers on here. It's just hard to write out really long answers. Question? Sure, the interpretation of this one was, when somebody brushes their teeth 0 times a day, we expect their longest relationship to be 92.47 weeks. Question?
Why can't you just say about 92?
I would just, when I write it, if I were to say it to a person, I probably wouldn't say the decimals like we said over here. But if we were writing it on the test, I would just do the decimals.
So like when you're graded,
just 2 decimals. 2 decimals. We got questions. Make sure to only whisper between each other. B0 is the y-intercept. And how do you know which one is B0? The B1 will be connected to the x variable. The equation is y hat equals B0 and then plus or minus B1x. So whenever you see the x variable, that is the one that is connected to B1. So great question right there. Go ahead.
Okay, so this is not your general question.
Sure. Yeah.
But for the questions on the homework where we've had to like plug in stuff to Applet to get specific values, we won't have to do like
Sure.
37.89%, right?
So the question is, on the homework assignment, sometimes you have to put things into jump. Sometimes you have to use the regression solver. And here's the thing. On the test, we obviously can't have you doing technology, right? Actually, in classes like 320 and 474, where we do more programming, we actually have people do tests on their computers. So we will actually have people do programming because that's what we expect from you, right? But in this class, we're not trying to get it for you to be a programmer or know how to solve everything on the computer. It's more of a theoretical thing, but we do use the computer to solve problems. So there's problems that we wouldn't expect you to do on a test, i.e. like find correlation or use the equations to do the regression solver or stuff like that. But then maybe you go to another class like biology or a social science, and you're like, oh, let's do this regression. No one's going to do the regression by hand. Everyone's going to put it into a computer or technology. So that's where we hope to give you the computer or technology kind of understanding that when you're in another class, then they're like, let's do this regression. You can do it. And that's our goal. So it's not very good for doing for tests, but it is a skill set we want to help develop with you that you know how to use statistical software. So great question. And multiple choice or short answer, multiple choice, short answer, all that good stuff. True, false is. You guys like true, false? Sometimes. Where are we going next? What topic we covering? Normal model for? Let's go big. Let's do it. What do we got right here? Between what z-score is the 60th percentile found? If I ever heard a test question like this, what's the first thing you would do? And I'll probably show it up here. I'll probably have to exit. Yep, and I would start drawing that immediately. Now, I'm going to drop huge hints for how I would do this. I'm going to have to hop out of this. So we're going to go to David M. Lane. I want to make this very clear. David M. Lane applet. So, and they might be saying it online. Someone in class got you, Jacob. So it's online. So let's go over to the David M. Lane applet. And here's what we need to do. Whenever we're presented with a question on the normal model, or we're given applets, if a test question were to say something like, test scores are normally distributed with a mean of 80 and a standard deviation of 10, you would immediately, if you're given this applet, put 80 where? Right where 0 is. You'd immediately write in 80, and then you'd start going up and doing this right here. Does this make sense? You would put the numbers below it. You can write all over your test. I'd put 80, 90, 100, 110, 70, 60, and 50. I'd put those numbers below there. Start drawing it out. You can even do your 68, 95, 99.7, and to do the 60th percentile, we only need 68. Because if 68% is the between -1 and 1, what is between -1 and 0? And what is between 0 and 1? They muted themselves. Someone came in and they didn't mute. I thought it was like an alarm outside. What percent is between -1 and 0? It was someone came in and was on mute. Go ahead. How do we know it's 34? Between -1 and 0 and 0 and 1? Because half of 68, watch out. I know you're thinking 32 because 32 is the total. 32 is the total above 1 and the total below -1, right? So if we were at 0, what percent of data would we be at if we were at 0? What, going through total, like adding up from -infinity to 0, we'd add up 50%. And then if we're at 1, we'd have added up how much? Do you see it? Do you see how I found these numbers? So between 0 and 1, or 0 is the 50th percentile, and 1 is the 84th percentile. So we've now narrowed it down. Percentiles go from the first or the lowest percentile to the highest. Do you want to be in the first percentile on the test or the 99th percentile on the test? 99th, which would mean you would be above the mean. Percentiles that are higher above the mean. So with this in mind, we'll make all the graphic go away. Remember, we said it should be between 0 and 1. So we can cheat right here and see if we got the right answer. The 60th percentile is, and that's not the 60th because it's above the mean, is right there. Was the 60th percentile between a z-score of 0 and 1? Now let's make this a test question here to see if you can do it. I'm going to ask 2 test questions, and they're going to be trickier. The first one's going to be a little bit easier, and the second one will be more difficult. Remember I said, and try working this out right now, I said that the average on the test was a what? I said, I'll type it in the chat. No, it's awesome, Garrett. I said it was an average of an 80 and a standard deviation of what? And so whatever you do, take about 60. I know you might get the answer instantaneously. I just did it in my head. And you're like, how did you guys do that? Don't say the answer too quickly. So what is the 60th percentile? Don't say it out. Someone might do it like that because it's with 10, it's not that hard to find this. So with this information, we should be able to find the 60th percentile. But remember, here on the curve is what? If I write my numbers below it, this should be what? This should be, what is below 0 right now? What should I write on my test? These are Brian's tips for taking the test. Throw 100 points. What should I write below 0? 80. I should write 80 because that's the mean. I don't care if the test doesn't put it there. I'm going to write it myself. What if the test had 80 below it, right? What if there was 80 at the start? What should I write below it then? 0. I should put my z-scores. Put the in context or the z-scores just to help you out to make sure your numbers look right. Because when we put 80 here and 90 here, I know the answer for the 60th percentile must be between 80 and 90. So now I know whatever I write on this test has to be between 80 and 90. So now let's see who gets the answer here. We talked about it a little bit. Raise your hand for that 100 points. Who's got what the score of the 60th percentile would be? Who's got it? Raise your hand. I'll explain how to get it once we see a hand raise. What would be the score of the 60th percentile? The score of the 60th percentile would be, raise your hand for 100 points or say it online, and then I'll explain how we got it. Uh-oh. So wait, this is the 60th percentile, right? What is this down here? That is the what? Oh, online got it. Nice job. Do what? That is, there's 40% above that, but the 60th percentile is where there's 60% shaded below it. So does that make sense that that is the 60th percentile? Does that make sense? So, and this is the z-score for it. Now remember, what does a z-score tell you? Exactly. So this, we should go up about 1/4 of a standard deviation, right? Oh wait, what's a standard deviation again? In our context with the 80 and 10, it's, well, is it 80 or 10? It is 10. So we need to go up 1/4 of 10. What's 1/4 of 10? 2.5. So watch this. If I change this to this right here, it's 82.5. Does that make sense? Now, mathematically, what we would do is the following. We should take, and we can solve this mathematically, we can take a z-score and turn it back into the observation by doing the following. All we're going to do is take our z-score and times it by the what? To turn a z-score, and write down these notes if you don't have them, to turn a z-score back into an observation, take your z-score and times it by the what? Standard deviation, and then add it to the boom. And this is if you remember the formula, observation minus mean over standard deviation, thickness, observation minus mean over standard deviation equals z-score. If you reformat this, you would get that the observation equals mean plus z-score times standard deviation. This is a very quick abbreviation on this, but observation minus mean over standard deviation equals z-score. So if you rework that, you could get that the observation equals the mean plus z times the standard deviation. Does that make sense how I can mathematically rework it? And just think about what a z-score is. It's how many standard deviations you are above or below the mean. So that's what we did right here. So, and I'll do it one more time. I think there's some questions. Sure. So I know this was kind of a quick problem right here, but I just want us to think in context, what does a z-score mean again? And let's make our lives even easier. Your friend says to you on this test that they got a z-score of 2. What did your friend score on the test? Yes, you are correct. I was trying to remember our numbers. Remember, it is a mean, and you just did it right there. You actually just did it. Did everyone, do you know how to do, if your friend says their z-score is 2, they made a 100. Because what did you do with that 2? You went to 80 and went 90, 100, right? But when I show you this graphic here, what is it telling you? It's saying your friend basically told you, my z-score is 0.25. So how many standard deviations do you need to go above the mean? 0.25. So how would you do that mathematically? You would times it by the standard deviation. Does that make sense? I think the harder thing is when it's a decimal. So your friend is really sad. I mean, they didn't do that bad, but their score, and I'll show it in context, their score, oops, wrong number, I'm giving the answer. Their score is a z-score of -1. They're not too sad, they're not happy, but their z-score is -1. What did your friend score? 70, does that make sense? Your friend's really sad, they got a -3 as their z-score. They failed and they made a 50. Does that make sense? And so when you see this z-score right here, remember that this is the z-score for the 60th percentile. If I were to give you the z-score for the 80th percentile, which will be right about, do you see where my cursor's at? How do I know it's there? Because it's, whoops, a little over. It's right below 1, right? Because 1 is the 84th, so the 80th must be a little bit below that. So if your friend told you they were the 80th percentile, can you please do a decimal one, Brian? Oh yeah, let's do this one right here, Keenan. So if your friend told you that their z-score, they were in the 80th percentile, what was their score on the test? So we'll pause and try to work this one because you understand the concept if you can do this one. If you're given a z-score, how can you put it back into the context? We take the z-score, we take the mean plus the z-score times the standard deviation. Try doing that right now. To turn a z-score back into the context, You do the mean, you do the z-score times the standard deviation to add it to the mean. And who's got it? I'm gonna call it, who's got it? Basically, do some decimals on that, Sydney, and you'd be right. So do you see the z-score on here? And go ahead right here. So we take this z-score. The z-score is 0.841. This is the z-score. And then in my problem, what is the standard deviation? The standard deviation was what for the tests? 10, and the mean was what? 80. So we're going to do 10 times, we'll remove this, 10 times this, which is a move of the decimals. And then we get that, and we do what? We add that to the mean, and then we can double check our answer. We should get 88.41, and we double check it by going right here, and we get 88.41. It shows a few more decimals, but that's the answer we should be getting right there. Nice job, Sydney, and in class. I'm doing 100 for asking that question right there, and hopefully that answers. But now, if you understood that, you have a level 5 understanding, and I'm going to give this question, and we'll take this question. So here's a harder question. You guys ready? Tell me the test score of someone who's at the 20th percentile. So think about that for the moment. If you can get this one using this graphic, you have probably a high-level understanding of this concept, of how to use these curves. And I think, Erin, you had a question?
I was just going to know what give us the score that we need to use.
If we give you graphics, one of the graphics, like if we give you 4 or 5 or 6 graphics, there'll definitely be the information you need. We'll never have you actually have to calculate it on a calculator, but go ahead. Oh, yes, Mark. Mark seems to get it. Got it. And you will have all the information on the test. You will be either given pictures or expect to know the empirical rule. So what would be the 20th percentile? Close. How much of the curve is shaded white right now? How much of the curve is white? 20%. Wait, didn't I ask for the 20th percentile? Closer.
76.
So this is the top 20% right now, which is the 80th percentile. But what if I were to flip the graphic? How much is shaded down there now? But what is happening to the z-score when we go from the top 20% to the bottom 20%? And isn't that what I asked for, the 20th percentile? Well, what answer are you? But be careful. Now, what are we? Wait. Everyone pause. So everyone listen very carefully, because here's how we're going to check our work. And they're getting close up. Mia and Luke got it online. Nice job, Mia and Luke. There might be a rounding issue on one of those. It looks like Mia, you got it. And Luke maybe just typed the wrong thing. So I want to explain how this is obtained. And these are one of the hardest questions. If you understand this, you understand how to use these graphics very well and what's going on. Does that make sense? We went to a level 8 question. This is tough. I understand. So if you don't get this, you're not going to fail the test. This is like there might be one hard question on the normal curve at this level. So don't worry. We're just doing some of the hardest questions we can do today, right? That's what we want. So I like it. There's some energy here. So what are we going to put at the center here? We're going to put what on our curve? 80. And what is going to go right here? So the answer we give should be a lot closer to what? 70. Does that make sense? We got a frame of mind that our answer we give is going to be closer to 70. So we're going to put 80 right here because that's the mean, and 70 right here. You can also kind of see it if you flip it, because this is closer to 90. And now imagine this. Remember our previous answer was 88.41. You remember it was 88.41? Well, how much is that 88.41? That is that much above 80 in the positive sense, right? So if we were to go and flip this graphic, wouldn't we just see how much below? And we'd get that right there. Does that make sense? You could also take the z-score right here. Remember, we have this as the negative z-score. So now that we know the z-score, why don't we just take the z-score and turn it into an observation? How would we turn this z-score into an observation? What do? Right, let's do it. Let's take that standard deviation and let's do 10 times, and we're going to go 0.841 negative, and we're going to multiply, and then all we're going to do is do what to that now? Add it to the mean. So we're going to add that to the mean, and we get the same answer here. Does that make sense? The test probably would give us a picture like this right here. So the test could give you a picture. I'm going to do one last extension of this. You guys want me to bring it to a level 10 question? Yes. There's like a no. Don't worry, we will review. We'll probably do a few more and we'll review. I know these are some of the tougher ones. Here's where I bring it to a level 10 question. Could you use this graphic right here to find the 80th percentile of scores? Could you use this graphic? Yes or no? Could you use this graphic, and I'll answer all the online some over here. Could you use this graphic to find the 80th percentile of scores? Do you remember those z-scores we were just using? Remember that 0.841 we were just using? Do you see it down here? The reason being, and what I would write on this, is for this middle block, sorry guys. For the middle block, I would write what over it? What percent of area is in the middle block? I think 60. They're saying skip the question. And then the top has how much in it? 20. And then the lower portion has how much? 20%. There was a glitch in the matrix right there. Oh, that's too old of a joke. So what would be this point right here? This is the top what percent of the curve? The top blank is above it. Top 20%, or it's the 80th percentile. Lots of ways to talk about it. It's where the top 20% is, or it's where the 80th percentile is. Does that make sense? Which is the exact spot we were looking at a moment ago. So a little tricky. Are we going to, I doubt there'll be a level 10. I just like to go the highest level question. We just kind of went up in tier every time, made it more difficult. But these are the tricks we need to know that we need to write on our test. We need to put the in context below if it gives us the z-scores, or the z-scores if it gives us the in context, and we need to put the percentages on the curve, whatever information we can to help us out. I know these are the tougher questions. And I think we answered all the onliners. Go ahead, question class. So the percentiles can be obtained the following way. I'm going to pull up a really great graphic right here. If we know 68, 95, 99.7, we can use all those numbers right here. Oh, I'm going to get to do, there's times I miss teaching in class, and this is one of my favorite graphics to teach in class. Let's show this graphic right here. And they have this really great graphic on this page. Let's talk about it. Now, what do I mean by 68, 95, 99.7? Let's do this. Let's go on a ride onliners. So we're going over here. So I'll keep the camera facing this way. So 68, 95, 99.7. That's because in between here and here is 68. I better put it here. This will probably work. So 68 is in between here and here. What is total outside? 68 inside. Total outside is what? 32. Does that make sense? What's one of my hands worth? How much? I'm just going to do limbo. What is in between -2 and 2? How much? 95. What is total outside? 5. So what's one of my hands worth? Does everyone understand how we're doing that? If 95 is inside, total outside has to have 100. What's that? 5. Then what's one hand worth? You take 5 and divide it by 2. Does that make sense? 99.7 is the next one. So what's that leave total outside? 0.3. So what's half of 0.3? 0.15. Now we go backwards, because remember we said 2.5 here, right? What is 2.5 minus 0.15? 2.35. But now we're going to use this 2.5, and we're going to subtract it from what was this number? And so what's 2.5 minus 16? Then we're going to take the 16 and minus it from 50, and what do we get? And then we repeat the numbers. That is my inside-outside trick, and that's the best way to get the numbers. Now, when you write down every one of these numbers, I can't go too far away, they won't hear me. When you write down every one of these numbers, what should they all add up to? Nice job online with those numbers. 100. And what should half the curve add up to? If I take the numbers, all these numbers I wrote down, and go between -2 and +2, what should they add up to? -2 and +2, all those numbers should add up to 95. If I add up these numbers outside, these numbers on the lower end should add up to what? How about below -1? They should add up to 16. You know what I've told people to do? Flip over your test and write down all these numbers. You can write this down in a minute or two and use it as a resource to double check. Sometimes there's empirical rule questions, so knowing these numbers and how to use them is a great way to do well on these questions. Now, the percentiles can be obtained. Remember, this right here would be the 0.15 percentile, right? How much have we added up at this point? 2.5. How about here? 16. Then the middle point is what? 50. Now let's add 34 to 50, and we get 84. And then this is 97.5. Rather than adding up all the numbers, just remember how much is above here. How much is total above my cursor right now? 2.5, so how much is below it? 97.5. I'm going to throw a big 100 points. What percentile is this? It's the what percentile? Raise your hand. Tell me what percentile that is. 99.85. A lot of people forget and they say 99.7, 99.85 because how much is above it? 0.15. Does that make sense? I often see that on the test where people, if we ever do something like that, people usually put 99.7 because they remember 68, 95, 99.7, but there's only 0.15 above this right here. So that's just the practice and understanding what's going on with the curve. Does the normal curve usually apply to stats exam scores? Yeah, it actually kind of does. Stats exam scores are pretty normally distributed. Let's hop back in here. During the last, we'll try to do a few more of these because I think we've done pretty well, and I kind of hop us out from these if we need. What do you guys want to talk about now? Graphical display. I tell you what, you guys are free to leave anytime. You guys want to go to 6:30? Sound like a good endpoint? We'll take, you guys can leave. I can't hold you here. So you can leave now. Graphical displays for 400. Let's go right here and say, which of these is not a categorical display of data? Someone raise your hand and tell me a categorical display of data. No, categorical display. That is a variable. You are correct. Go ahead here. Pie chart. Bar chart. Bar chart in order. A bar chart in order would be a Pareto. So we have prepared ourselves for this question. Which of these does not look to be a categorical display of data? We didn't say mosaic. What is a mosaic plot? It's used for two categorical. So that's a bivariate. And that's fine. It's categorical. Mosaic is a bivariate categorical. Pie charts and bar charts go together. Bar chart of your favorite pie chart of your favorite bar, and stem and leaf is a quantitative display, univariate quantitative, that shows you the numbers. We saw one earlier. So great job there. How about we go here to 800? We see what we got. Oh my, we got a display here. What is the proper measure of spread? And I love this question. What is the proper measure of spread? You already know it. You got it online. They're doing it online. They're getting the answer. How did we know this? Whenever we ask for skewed. So here, let's write our notes for those who don't have it. Is anyone visiting the class today? Yeah, hey guys. Oh, we got, it's all right. I love when we get visitors. Okay, let's write this down right here. We need to make this so the onliners can see it too. If you do not have this table, make sure you write it down. This table is a big help. Okay, let's see. So write this down. Okay, so we have two ways that data can look. It can look skewed or it can look normal. We have two measures to look at. We have a measure of center and we have a measure of spread. We have a measure of center and a measure of spread. So when we look at our data, we have to ask, is it skewed or is it normal? And the first thing you looked at is you saw this histogram right here, and you saw that the histogram looked what? Skewed. So when it is skewed, and we'll put them this way, we'll put skewed in red, because skewed is kind of not as fun to deal with. Make it lighter red. And then we'll put here this one in blue. I like colors. And let's go here to center. So the center for skewed data would be the what? What is median, because it's based on position. Where the spread would be the IQR. And then for normal data, the center would be mean, and then the spread would be, you guys are amazing. There we go, standard deviation. And if you notice here, we have everything kind of grouped up. Does that make sense? That measures of center are mean and median, where measures of spread are IQR and standard deviation. You would never use the median and standard deviation together. You shouldn't cross pass on these. You're going to say, is my data skewed? Then the measure of center is median, and the measure of spread is IQR. Is my data normal? Then the measure of center is mean, and the measure of spread is standard deviation. Just like when we do z-scores are calculated from what two things? A z-score is calculated from the mean and standard deviation. So those two go together. Think about what the median is. It's based on the what percentile? The median is based on the 50th percentile. The IQR is the range of the middle 50% going from Q1 to Q3. Isn't that also percentiles? So both of these on skewed data is based on percentiles because outliers do not impact percentiles. It doesn't matter if I go to this chart right here and I take this data point all the way here and move it all the way down. Would that change where this middle line is if I move this point all the way down? Would it change where this Q1 and Q3 are? Not at all. Let's ask a real quick question right here. What is the range of this data? It's a little bit more than what? Raise your hand, see if you got it. What is the range of this data? Not 3.8, only a little bit more than 3, right? Because this is maybe 0.8, and that's 4. What is 4 minus 0.8? It's about 3.2. And we wouldn't ask you to exactly figure it out. Maybe we'd put the dot over 1, because then if you said something like 2.4, we'd be like, uh-oh, you didn't see the outlier. Or you might have just said 2. So remember, the range goes from the min to the max. When we look at a box plot, we should be able to identify all the 5-number summary. So let's try to do this right now with this graphic. What is the 5-number summary in this graphic? Where is the min at in this graphic? Right here, 0.8-ish. Where's Q1? Careful, raise your hand high because this is going to be a tricky one. Q1 is what? Look right here. No. Like 3. So many hands. What is the median? 3.256, I don't know. What is the Q3? Whatever that is. What's the max? And it looks like there are not observations up here as far on this line because we don't see outliers. They stopped right at 4. Does everyone see that? Even though there's a bin there, that bin probably starts at 4 because you read from left to right on the bins. So that bin starts at 4. So those are probably the people with the 4.0, and I can tell that because I could trace this down right here. Look at the box plot to see the range of the data values. Let's try another one. That was a really good question right there. Trust review. I like graphical displays. What did I put in here? Oh, this is candy. I didn't bring candy. I'm sorry, guys. I figured, I was thinking in my office, I was like, what could we do for a really fun review? Because I figured there'd be a bunch of people today. And I was like, let's do the Jeopardy. Oh, do I have the crazy videos in here? Maybe I do. Which of the following is not a quantitative display of data? Which of these is not quantitative? We don't really do dot plots anymore, so that's a right answer still. Go ahead. Bar charts. I think a lot of times people confuse bar charts with box plots. They got these in them. Bar charts and pie charts go together. Bar charts are univariate displays of, bar charts and pie charts are univariate displays of categorical data. Histograms, stem and leaf, dot plots, which we really don't do anymore, are quantitative displays of univariate data. Let's see, that one, we'll try to hit another big concept here. We're gonna hit a video, sure. Stump the other team, we won't do this one. This is where you label a bunch of graphics. Later on, I felt like this was kind of wasting too much time. We're gonna hit the high points. Interpret R squared. Oh, this is good. This is going back to the brushing your teeth problem. Remember, we're trying to explain how long someone stays in a relationship with brushing their teeth. And you could basically round this to 0. I'm fine with that. So remember, this is the brushing your teeth problem, trying to explain how long you're in a relationship. So what's the X variable? X is brushing your teeth, and Y is how long you're in a relationship. So try to write the sentence now. Remember, all you need to know is R squared, X, and Y. So try to do it now and see if you can write it out and be able to interpret R squared in context of this problem. So Y is how long you're in a relationship, longest weeks in a relationship. X is brushing your teeth, and R squared is basically 0. And I'd accept that for this right here, basically 0. Who's got it? Close. Close, close. Yes, that's it right there. So as the number, oh, no, Sydney, it looks like you might have done slope, Sydney. Remember, R squared is blank percent of the variation in Y is explained by the variation in X. So about 0% of the variation in your longest relationship is explained by what? Number of times you brush your teeth. Does that make sense? So don't brush your teeth. No, do brush them. 0% of the variation in how long you're in a relationship is explained by the variation in brushing your teeth. That is correct. So Carol, I'm throwing you 100 points and 100 points in class for answering. Great job. And here's the answers right here. Remember, you need to do the X and Y in context of the problem, but this is the general format right here. Question? Question? Do what? Yeah. Let's continue on. Let's see what we have right here. Give the slope in context. Great review question now. Reject. No. Luke, that's not a p-value. That's not a p-value. No. I'm trying to think if we have p-value stuff on here. I'll go back to that in a moment. That's not a p-value, though. Oh, no worries, Luke. So interpret the slope. Who's got the slope here? Did we do this one already? We didn't do this one already, did we? Who's got the slope in context? It's kind of sad. It's giving you life advice here. And Luke, this one's actually not statistically significant, so this is all random chance. Go ahead.
For each change in number of times daily, expect your longest relationship to decrease by 3.70.
For each additional time you brush your teeth daily, we expect your longest relationship to decrease by 3.7 weeks. Does that make sense? I mean, it doesn't really make sense, but it's like what all these things you were taught when you were a kid are wrong. So statistics. But actually, the thing is, remember, we just said that r squared is very close to 0. So this relationship right here is really not a strong one. It's probably just random chance. Does everyone see how this graph looks kind of crazy? Do we? I'm trying to think if I still have this data. Yes. So we don't really talk about the slope being logical, which I think the last question right here will be intercept. Or we should have an intercept. Drawing contest. Don't worry, we won't draw this. All right, cool. We'll continue on. That's our little bit of fun for the moment. All right, hopping back in here. Let's do some more review. We got more class time. We got more bonus time. So can we do another normal model question? We did a lot of review on regression. Let's hop back into normal model, and maybe we might not get another video here. Uh-oh. Raise your hand question. What are 3 ways we can check to see if something is normal? We got some p-value stuff coming up right here. What are the 3 ways we look to see if something is normal? We can actually use review right here. How do we check 3 things to see if it's normal? Who can tell me? I want to see if a distribution is normal. What do we got? 3 ways to see if it is normal? We can do a QQ plot. I'm going to see if high school GPA is normally distributed. So I'm going to do a QQ plot. Here's my normal quantile plot, and it doesn't look really straight, does it? I also heard histogram. Do you see how there's a bunch of outliers? Should normal things have big outliers? How would the QQ plot look? So first way, look at the histogram. If it looks kind of mound normal shape, normal. Question? Do what? In jump? Or scatter plot with what? The jump, go ahead. Sure, I'll show that at the very end. How's that sound? Awesome. We'll make some scatter plots here at the end. Remind me, we shouldn't, and I think they got it online. So the 3 ways to check for normality are, did you have a question too? Or?
Yeah.
Go ahead, guys.
I think you said the answer for
Oh, which one for the?
It's the 60th percentile.
Oh, the 60th percentile?
Yeah.
Between 0 and 1.
0.841 and negative 0.841. Did you answer that?
The 60th percentile?
Yeah, this one.
Mm-hmm.
Is it 63 point something? The answer?
The answer for what would be the score of the 60th percentile, I believe, is 82.53. So 82.53. Wait.
No, it's like between.
Yeah, you were.
Oh, where is it between on the z-scores? It's between, where would it be between? Is this the one?
No.
Wait, which question? I'm so sorry, everybody.
It was between.
Wait, I'm so confused with this. The 20th percentile. Okay, wait. We're going to pause. So the question is, where is the 20th percentile? Is that the question?
No, it was between. You can go between.
Yeah.
Not below. Go between.
Oh, go between. Yes.
0.8 or 1.
Oh, okay, all right. This one right here, right? Oh, this is the level 10 question I said, right? So wait, I want to repeat what this question was with this, just to make it very, very clear. The question here is as follows. What is the 80th percentile? Does that make sense? And so how could we use this to get the 80th percentile? Where would the 80th percentile be on here? The 80th percentile would be right here. And how do I know that? 60 plus 20. Does that make sense? And so all of the and this is the exact same graphic that we had when we did it like this right here. And you see how that's the same number? So what would we do with this to get the 80th percentile? We would take the z-score and multiply it by the standard deviation, and then add that to the mean. Does that make sense? That gives us the 80th percentile, which we can see. We can look at this in context. Sorry about that, guys. Thank you for bringing me back to that. If we go to this and we put it in context, we will see that the number that we got on the calculator is that second number there, 88.41. Does that make sense? Great question. I'm throwing 100 points for pulling us back to it. I always want you guys to see these normal curve stuff. It's a little tricky, and I appreciate you pulling back to it here. So let's continue on with this one right here. First way, one, and it will be in the video, your question. So it will be uploaded. That's it. And so the first way is to look at the histogram and to see if the histogram looks normal. I agree that this histogram looks kind of normal, right? Then the second way is to look at the QQ plot. Do you guys see the bend in it? If it's bent, that's an indication it's what? Not normal. The last way, and they said it online, is to do the what? Goodness of fit test. So we need to do a goodness of fit test. And let's go in here and fit the normal with the goodness of fit. And here's the p-value. Now, what is the null? Read the bottom sentence. What is the null for the goodness of fit test? The null is that the data is normal. When the p-value is low, reject the null. So is this p-value here low? You will reject that it is normal. So I'm actually going to show how to make a scatter plot too right now. You can do the correlation scatter plots with multivariate right here under the menu. You can pick two quantitative variables, and I want us to see the following though. Remember, the null for this one right here that we just did was normal, but when we do this correlation right here, the null for correlation is that there's what? What is the null for correlation? That there is no correlation. So what are you going to do to the null here with this low p-value? Reject and say that there is correlation. We can go back and do the regression one that I think we have open. Do we still have our regression open? Yes, we do. Now look, you have p-values down here. Do you think we should care about the p-value of the intercept or the p-value of the slope? What would be more the slope, right? Because the slope is the xy relationship. So the null for the slope is either that there's no slope or there is a slope. What do you think the null for the slope is? Is that there is, say it again? No slope. Like with correlation, it's no correlation, alternative correlation. With the slope, no slope, and then the alternative is that there is a slope. And look at the line real quick. Does it look like there's a slope to the line? Like an actual real slope? And is the slope statistically significant? Yes.
If it's low in a slow context, you would say that reject it, say that there is one.
Correct. In this context, like there's one on the practice test like this, you would say, I reject the null that there is no slope, or we'd say, this slope is unlikely by random chance, i.e. low p-value, so we have evidence that there is a slope to the line. Question?
Where does null?
So the null, are you in our class?
No.
That's all right, it's a good thing. Because a lot of times what I'll do in our class is I might buffer us for future concepts. So I kind of threw the null in already. You will not see the null mentioned on this first test. You might see p-values though. So here's the quick shorthand. Who wants the quick shorthand on how to handle all these p-values?
Yes.
The quick shorthand, let's write it down, a cheat sheet so we can know how to handle them. So the cheat sheet for handling the following is if we're testing for normality, we will assume what? So let's write testing normality, assume normality. And we won't even mention null here. Testing correlation, I learned. No correlation. Testing linearity, no linear relationship. So we saw this just a moment ago, and we'll pull up the graphics. To test normality, we need to do the what test. Let's put a few notes on here. To test normality, we need to do the what test. So that is done via the goodness of fit test. Does that make sense? Because you'll test a normal to see if it's a good fit. When the p-value is low, so low p-value, evidence not normal. Because that's the opposite of normal, right? We're going to assume it's normal till we have a low p-value, which is evidence of not normal. Does that make sense? To do the correlation, well, we're just going to do find the R value or the p-value for correlation. So you will see correlations, and then you will have a p-value for the correlation. So what would a low p-value indicate about the correlation? Be careful. Remember what we assumed to start. Oh, you're right. Good. So with a low p-value, we would assume we would have evidence of what? Evidence, yes, evidence of correlation. Does that make sense? So just do the opposite. If you assume no correlation, if the p-value is low, you have evidence of correlation. So once again, the last one here when we're testing linearity, so like let's actually put testing the slope, because that could be confused for something else. Find the p-value of the slope. And what we would have here, low p-value, evidence of linear relationship. So if the p-value for the slope is low, the line actually does a good job of describing it. So you assume that there's no linear relationship to start, and you would look at the p-value of the slope, and we'll bring up the analogous output right here for this last one, because I think I'll still have it up. If you notice this output right here, there we go, we got it. So the output on the screen shows the p-value of the x variable, and the x variable is the slope variable, right? So the p-value here for the x variable is low, so I'm going to reject, I'm going to say I don't think that there's no linearity. That's weird, right? I don't think that there's no linearity. Don't think that there's no double negative. Thus, I think that there is. So basically, in the classical sense, which we'll be doing later on, I would say I reject that there's no linear relationship. I have evidence there is a linear relationship. That's more the classical. We get into that. I always kind of buffer us for future knowledge to make sure we have these kind of like background understanding.
So is the
Question.
p-value for correlation, is that
I'll pull that up here.
R or is it not R?
The p-value for correlation is not R. Great question. The p-value for correlation is not R. And so to get the p-value for correlation, you'd have to go to like multivariate. There's always a possibility something like this could be displayed on the test. And let's look at, we should get 3 p-values here. So I'm going to go to pairwise correlations. And you can see the different correlations. Which of these correlations is statistically significant? Which of these correlations is statistically significant? Languages and starting annual salary. And you see the correlation here is positive. So the correlation is not the statistical significance. Statistical significance is a great thing to remember. Is always determined by what? Statistical significance is always determined by a blank that is, say it again, a p-value that is lower than 0.05. Do everyone hear that? Statistical significance is always determined by a p-value, don't have a voice there, that is lower than 0.05. You will be given p-values. We'll never make you calculate those. Great question, Adea. Brian, do you know how to find the B1 and B0? We will not give you those formulas on the exam. You will not use them. You might have y hat equal B0 plus B1x. You will not have the standard errors and those on the exam. Does that make sense? You don't have to do what the regression solver does. Great questions. We will need to use the normal distribution chart to find the z-scores. You will not use z-score tables on the exam. Keep asking those questions. Let's see what questions you guys and gals have. I'll take all of them right now. Go ahead. Chapter 7, a lot of the good parts of Chapter 7, probably one of my favorite ones, which I know you guys hate. This is probably the best question on the homework, is the, aside from the part on the SAT question where it has you use the regression solver. Does everyone know where the regression solver is under modules, where it'll solve that part for you so you don't have to do the by hand calculations? That question has you do things like predict someone's score if they made an 800 and find their residual. That's a really good question. Does everyone know the SAT question? So the SAT question on my Pearson where it says like, someone made a perfect score on the SAT, what is their residual? So, and we did that in our 2 videos ago, right? We did that at the end of class, so feel free, if you can't find the videos, I'll send you guys the links if you're in another class. But we did that question, we talked about it, because that one actually has you solve using the regression equation. Then you have to know what a residual is. So you kind of have to do a multifaceted problem. It's probably one of my favorite ones that uses the thing right there. The question here, go ahead. We'll see
In what situations do you use R and in what situations do you use R2?
R is for correlation. So all Chapter 6 problems that talk about correlation would use R, and then regression problems use R squared. Because R squared is the ability of the line to explain. So you'll see a little difference in the output right here. I mean, R squared is an aggregate of R, but the graphic on the right is a kind of quick summarization of Chapter 6, where the graphic on the left is a summarization of chapter 7. Kind of understanding what's going on right here. Do you guys remember in the notes we had a correlation matrix where I asked you guys what was the most correlated and the least? The most correlated would be number of languages and starting annual salary. You could also look down here and see that because it has the highest absolute value of correlation. We'll look at the online questions. What do you say about statistical significance? Oh, yes, that you are correct, Brianna. What should I eat for dinner? Hard Knocks pizza. That's always. What is the topic, the test you anticipated the most? A lot of people have trouble with regression and normal curve. And if you notice, that's where we focus a lot of our attention today. We didn't do much with bar charts, histograms, and Pareto's. But you should still know those. You should still know.
So like, how much is it you're talking about? I don't know.
Sure.
You did the strong, like finding the strong
Mm-hmm.
the weakest one.
Yep. The strongest would be the one closest to positive or negative 1. So this is the strongest. You see how it's 0.07? That's closest. And the negative right here, the weakest is this one, not because, oh, I'm wrong. It's this one. Why is this the weakest? We could I'll do a bigger one right here. Closest to, say it again. Yep. What it is, they repeat. So what it is, and actually jumped us a little bit of coloring right here. So it actually, if you look across this one right here, everything on the other side repeats. Does that make sense? Like the correlation between GPA and age is the same as age and GPA. And the strongest correlation here is age and high school GPA. I think this is actually the data I made the graphic from, or it's very close to, because we asked a lot of the same questions. And then the weakest correlation might be pet expense and age. Do you guys see any that are closer to 0 than this one? This looks to be the one that's closest to 0, right? And so since this is the closest to 0, it is the weakest. This one is not the weakest. It's the strongest because it's the closest to what or what? Negative 1 of 1. Does that make sense? The strongest correlation is closest to negative 1 or 1, and JUMP kind of does a little bit of nice shading for you. It makes it blue when it's closer to 1 and red when it's closer to negative 1. But the stronger it is, the further away it is from 0. And you can kind of see some of these plots showing that right here. Question right there. You could do either way because the flip side of the graphic is the same. Does that make sense? Because it's, in some graphics actually don't show you, they don't even repeat the numbers because it's the same numbers. But yeah, so you could say high school GPA and age have the strongest correlation, or age and high school GPA. It's the same, but great question. So there's not as many pairwise correlations. If you look at this graphic right here, how many unique pairs are there between this? There's how many unique pairwise correlations? 3. Does everyone see here? 1, 2, 3, and then those numbers repeat here. And that's why we do the pairwise correlations, it only does those. We've asked that before in the past. We've said, how many unique pairwise correlations are there? And there would only be 3. Question? Yep, 1, 2, 3. And then this isn't really a correlation because it's like saying your age explains your age. Well, yeah, if you know someone's age, then.
So you count under the numbers, yes.
Yep. Exactly. Where can we find the testing locations on Canvas? So let's show our testing locations again. Great thing, and I will send an announcement probably tonight. So make sure to email your instructor if you do not know where your testing location is. If you really don't know, you can email me. Probably don't email me as your first way to do it. I know I put important info in this one. I probably should have said test locations, but here are the following test locations. If your name is A through J, you will be in Daughtry. Is Daughtry engineering? Daughtry is which one again? We were just discussing this earlier. And is that where I'll be? I will be in Daughtry. So if you see me in a room, your last name should be A through J. And then we have here K through Z will be with Jamie Paul in AMB, which is Alumni Memorial Building, room 27. So just look at your last name, as long as you know it, and you will be in the following rooms. And I will post this again. Remember, it is online for you to see at any time under the important info, but I'll probably just say test rooms. That's probably a much easier thing to see. Where can we find, that's the same question. So you should know, and if you want, I can probably look it up afterwards if you're really wondering. Like, I've got all the info. Any other last questions? I'll probably end the recording here in a moment. I'll take all the remainder questions. I think the best way to study is to, a lot of people have printed off the practice test and just work the questions. Once you work the questions, watch the videos. But you can't just watch the videos and be like, I got that, I understand that. You actually have to like sit down and like make your brain just like work through the problems. So work through the problems, then maybe watch lecture reviews or go through the notes. And I think that's your best strategy there. But the practice test is a pretty good example. Here's a scary thing. If you only know the practice test, you'd probably make a 60. But I mean, imagine if I just gave you the practice test, you studied it for a few hours without ever taking this class and you knew it, you can make a 60, right? It's not bad, right? But what am I saying here? You can't just study the practice test. You can't like skip the whole semester and take a practice test. So it doesn't show you everything, but it's a good idea of what's on it. It'll help. It just won't get you an A with just taking the practice test. So it's very good though. Please use the practice test, but try to learn. So we'll keep this going here. I'll mute the webcam. So I don't know if you'll want to be on webcam or not. I'm going to mute the webcam. I am still here, online people. So I'm going to stop the video, but I am still here. Hey, bring your computers up if you got questions. Come over. Yeah. Let's see what your shirt says. I like that. If we wait, the what? Yeah, sure. We'll do that.
Thank you.
Hey, you're welcome. Great job.
I don't understand.
Sure.
4.
Yeah.
So I got the graph, but I
So
don't
this is
understand
kinda like-
why they did 150.
So imagine this. You pretend this says 143. So we'll take decimals up, right? So if the 25th percentile is 143, how much below 150 is 143? 7. So if you were to flip this graphic, then this line would be over here, right?
Oh, so you'd
So
add 7.
You'd add 7. So maybe, yeah, you got it. So you would take the difference, and it would be said basically 7, and then you would add that difference. Great job. No, once I said it, you're like, that's great. And that's what we want to see. And that's kind of like what we did today, right? So that's why I kind of allude to those, because I'm like, wait, now you got to reverse. And so this one here? Yep. So when we do this, we always want to draw our normal curves and scroll down just a little bit more. And if you notice here, we do our 68, then how much would be above -1? If you're at -1, 68 is between 32, and total above would be how much if you add these numbers? Total above would, there you go right there. Because you could do 16 below, 84 above, right? And then if 2.5 is below, how much is above here? So if 2.5 is below, then how much is total above this point?
How do you know you're looking for 84 though?
Good question.
That's
Scroll
what-
back up just a tiny bit. So it says that this individual, so it says, well, first it tells us 2 years, right? So the first thing we want to do is turn 2 years into a z-score, which we just did,
Yeah.
right? So we know the z-score is -1.56. So then what we're going to do, and here I'll draw it up here real quick. We're going to hop over to graphic. So what I would do if I was taking this on the test, sorry, eyeliners. If I annotate on the screen, they can't see, but I'm so used to. So what I would do is I would draw my normal curve, and then, oops, here we go, you ready? Draw a normal curve, and then I only really need to plot certain numbers, 0, 1, and 2, and these are negative. And then we know that the z-score is right about here, right? So what I'm going to do is I'm going to say that the area between -1 and 1 is going to be 68. And then above here is 16. I know that because below is 16, all that good stuff. So the total of this right here is 84.
Okay.
Does that make sense? And then in between -2 and +2 is how much?
95.
95. So then if I extend this out, there'd be 2.5. And then the total is 97.5. So when I shade in this area right here, it has to be less than, like if I shade this in total, so I'll shade it in kind of so we don't see too much blur. But this has to be more than 84, right? But less than 97.5. Does that?
So it's asking it has to be more. This is the lowest it can be.
Yeah.
This is the highest it can be.
Yeah,
in
so we
the
kind of boxed it in. We'll do another one right here real quick. We'll practice. So for onliners, if you can draw this out, if you're hearing this right now, it is still in the video. So if we were to say this person had a z-score of, let's say, -0.5, then, so they're right here, z-score of -0.5, then what percent of area would this be? We'll kind of maybe do a drawing. Like, first thing I would do is I would draw it, and I would look at it, and I'd be like, oh, well, that has to be more than what? That has to be more than 50, and 50 is a good number because that's the area right here, right? So it has to be more than 50. Just looking at it, it makes sense. And then, but the other arrow should be what? This arrow should be, it has to be less than how much? How much is this? Is this one?
less than
That's -1, correct. Yep. You're right. And so this is where we get good with the curve and we can practice, because we know in between here and here is 34 and this over here is 50. So this is the 50th percentile right here, and then 16 is below here is 16th, which means 84 is above. So this area on the curve has to be between 50 and 84. Does that make sense?
Yeah.
Yay! That's where you start to get it and you start to practice and know it. I'll see. I think we have an onliner and then in class. What are the things that we actually need to be able to calculate by hand? Z-scores. A lot of stuff where you turn z-scores back into observations, like a z-score to an observation to a z-score, using the regression equation. Let's write that down. Observations to z-scores. Z-scores to observations. Using regression equation, finding residuals, using residuals to solve problems. So the real equations are things like y hat equals b0 plus b1x, or residual equals actual minus predicted. So residual equals actual minus predicted is a great one, which is e equals y minus y hat. Trying to think what else. That's just a good kind of the main ones we use, right? And then I think, did I miss another one online? Brian, in your opinion? All right, that's, there we go. Questions?
The question we were on.
Yeah?
It said three things to see the normal distribution.
Yeah, three things to see if it's normal.
QQ plot.
So the three things to see if it's normal, look at the histogram. I don't suggest this one, though. We really don't look at it much. And then next, we check normal quantile plot.
You make other people, and that's the QQ.
Yep. So, and then goodness of fit tests. So
What's the goodness of fit test?
What it does is it literally fits a normal curve on top of your data. So no matter how your data looks, it'll take and fit a normal curve on top of it.
Okay.
And then it'll say, is that a good fit? Now, do you think this one I drew for a very right skew distribution? You're welcome online. Great job, Olivia. Yes, got it right this time. So for this very right skew distribution, does that look to be a good fit? It does not. You notice the histogram, so looks skewed, not normal. We'll do that one second. Unimodal, symmetric, that is by definition what normal is. And then looks skewed, not normal. It could look many things. Looks skewed, we'll put ... odd, because someone's like, only skewed, it could be bimodal, it could be, it could be trimodal, all these things. Normal quantile plot follows the line. If it follows the line, it is
Linear.
I know that's the trick, though. If the normal quantile plot follows the line, here, I'll go back to one, it is normal. I know it's weird because we just did regression, right? So what you do is you make the QQ plot here, and we'll go to one that's going to be really skewed because pet expense is very high. So that's ridiculous. Well, one, let's remove this outlier here. And yeah, someone spent $300,000 on their pets. I don't know about that. I know, right? And we're going to put auto recalc on here, auto recalc, and then oh, did I already remove them? Oh, they got pulled. What happened? Let's go to stack. Oh my gosh. Okay, wait, let's not go to pet expense. Who said they had $300,000 on pet? Okay, let's go to analyze distribution. Let's go down to how many selfies do you take in a month? And if you notice that's extremely right skewed too, I'll keep it. So now when we do this right here, the histogram looks ridiculous, right? Yes. That's not normal at all. So when I look at the QQ plot, which is the normal quantile plot, should be on here somewhere, my brain just blanked. There it is right there. Does that follow the straight line, the red line? No. So this is not really linearity anymore. It's looking to see if it follows what we'd expect via a normal. So that red line is what we expect via a normal, and our data does not expect or follow what we would expect via a normal. So now we can do one next step here, and I'll put the notes in here in a second. We can do what's called the goodness of fit. So you'll literally see a red histogram or a red drawing show up here where it fits the normals. And then it gives me the mean and standard deviation, and then I can see, was it a good fit? It gives the null an alternative on here, or at least the null, because it says the null is that the data is from the normal. And so if I assume it's from the normal, what do I do when the p-value is low? I reject. When the p-value is low, reject the null. When the p-value is high, just let it fly. So if you notice the p-value is low, it's basically 0. Yes. So you're going to what the null? It says the data is from the normal, so you're going to reject it. Now be careful. Don't think of all p-values as this. Not all p-values are testing normality. Only when you see this right here, the goodness of fit test, are you testing normality. So don't be like, p-value testing normality. No, no, no. P-value assume normal. No, no, no. There's the 3 different ones we talked about. You can assume it's normal, assume no correlation, or assume no slope. Just depends if you're doing normality, correlation, or slope, different p-value tests. And so what you notice is this doesn't fit well. Well, the histogram doesn't look normal. The QQ plot looks bent, and the p-value is low. So follows the line, normal, which we didn't do for our example, does not follow, not normal. And remember, it's not, for anyone listening, it's not linearity we're testing here. Goodness fit test, high p-value, what? And high p-value is above 0.05. This means it is, if the p-value is high, just let it fly, which means we're going to continue thinking normal. And then low p-value, low p-value below, low p-values below 0.05, not normal. And this is all being reported to. So you take pictures of anything, don't worry. I just want people to know too, you can always go back and review this, and if you can't find it, I'll send it to you. So yeah. What's your name? Robert, good to meet you, Robert.
Yeah, nice to meet you as well.
Yeah, I'll answer all questions. You guys can take, I'm in my office sometimes doing work, and people are just pulling out like recording, and I'm like, okay then. Yeah, just like, I'm like, hey. Yes, you're taking it at 8, right? I'll be there. What room are we in?
Doherty 501, I just checked.
All right, good. I guess I'll be there. No, I'm gonna go print all the tests now. But then I'm gonna go. I'll be back here at 8, and I'll be here tomorrow night till 8:30. It's gonna be.
Thank you so much for coming in for me.
Of course, no, it's not just you. There's other students too. So we give the 80 exam. So don't worry, it's not you, but I'm happy to do it, and thank you guys for all your hard work. Hey.
So it's chapter 7,
All right,
and I
we're
think
gonna.
I ended up with like a 92.
Sure, we're gonna end the video here, and we're gonna check some quizzes. Great job, everyone. No one's watching anymore. Ah. Oh, and I have to edit. Dang it.